Hi everyone, it's Linnea Tucker. This is CPM3, Module 3, Lesson 2. I think this is actually Lesson 3. Yeah, I think that's Lesson 3 on solving quadratic equations by factoring. This is Section 13.6 in the textbook. And I want you to grab your vocabulary sheet. All right. In the last lesson, we were factoring quadratic expressions. There were no equal signs. This time we're going to throw in an equal sign and we're going to change that quadratic expression into an equation. A quadratic equation is one that can be written in the form of ax squared plus bx plus c equals 0, where a, b, and c are real numbers and a is not equal to 0. The form ax squared plus bx plus c equals 0 is referred to as standard form. So number 3 on your vocabulary sheet says an equation that can be written in the form of ax squared plus bx plus c equals 0, with a not equal to 0, is called a quadratic equation. If a were equal to 0, this term would drop out and it's no longer quadratic. It would be a linear equation. Okay, so we have to talk about the zero factor property. Sometimes it's called the zero factor theorem. You might hear me call it either way. It says if a and b are real numbers and I multiply a times b and I get 0 as my product, then either a has to be 0 or b has to be 0. For instance, if I take 0 times 5, I get 0. If I take 12 times 0, I get 0. One of those factors has to be 0 in order for the product to be 0. All right, here's our first example. It says solve, and they give us the quantity of x minus 4 times the quantity of x plus 1, and they've set it equal to 0. Okay. This quantity here is our a, and this quantity here is our b, and we're multiplying together, and we get a product that's 0. So that means either my a here has to be 0, or my b here has to be 0. So I set each factor equal to 0, and now I'm going to solve for x. I'm going to add 4 to both sides here, and I get x equals 4. I subtract 1 from both sides here, and I get x equals negative 1. Now I'm going to check those solutions. I'm going to take an x of 4 and plug it in to the equation right there and right there. So I get 4 minus 4 times the quantity of 4 plus 1. Well, that's 0 times 5, which is 0. If I plug in negative 1 here for x and negative 1 here for x, here I get negative 5 times 0, which is 0. So x equals 4 or x equals negative 1 are both solutions to that quadratic equation. Okay, so there's our answers there of the problem we just worked. I want to show you what this looks like when I graph it. I'm getting just a little bit ahead of ourselves, and that's okay. I want you to show you that c in this equation right here, I replace the y with 0 right here. And what's always true when y equals 0? When y equals 0, you're solving for an x-intercept. If you take a look at this graph, isn't this x-intercept 4 or 4 comma 0? Yeah, and I probably have those labeled. If I graph this one here, the x equals negative 1, I have negative 1 comma 0. So when we set y equal to 0 in a quadratic equation, we are solving for the x-intercepts. If I take FOIL and multiply those two quantities out, I get this, x squared minus 3x minus 4. The equation for this curved line, which is called a parabola, is that. And that's how you would put it in a graphing calculator. But if you put it in the graphing calculator like that, you'd still get the same parabola, because this is just the factored form of this. And I'm just showing you when I replace y with 0, I'm solving for x-intercepts. Okay? You don't see the x-intercepts when the equation is written in standard form. You don't see them. The only way you can get the x-intercepts is to take standard form and factor it. And that's what we're going to be doing in this lesson. Solving quadratic equations. To solve a quadratic equation by factoring, first we're going to write the equation in standard form. Always, always, always. Then we're going to factor the quadratic completely. We're going to set each factor that contains a variable equal to 0. We're going to solve the resulting equations, and then we're going to check our solution in the original equation. Okay, here's example 2. It says solve x squared minus 5x equals 24. First step, is it in standard form? No, it is not. Standard form has the quadratic equation equal to 0. So I'm going to have to subtract 24 from both sides. So I subtract 24 here, which means I subtract 24 here. I get x squared minus 5x minus 24 equals 0. Okay, there's standard form. Now I'm going to factor. Is there a GCF? Because that's always the first step in factoring. Well, no, I don't see a number or variable that divides evenly into all three terms. So now we're going to factor, and I'm going to factor that expression. All right. I'm going to use the AC method. I know my A is equal to 1. B is equal to -5, and C is equal to -24. So A times C is 1 times -24, which is -24. And my B is equal to -5. All right, so I'm looking for two numbers that multiply together to give me -24 and at the same time add up to -5. So if I multiply 1 times -24, I get -24. If I add those two numbers together, I get -23. Well, the sign on this one right here is correct. So the bigger of the two factors has to have the negative sign. So let's try this one. 2 times -12 equals -24. When I add those two together, what's 2 plus -12? That's -10. Okay, let's try 3. 3 times -8 is -24. When I take 3 plus -8, I get -5. And that's what I'm looking for. There's the pair of numbers I'm looking for. Okay? Now, I didn't talk about this in the last video, but I'm going to talk about it here for anybody that's taking future math classes. This is the way I normally teach it and then show you the shortcut. And if you watched that extra video, you saw this. I'm going to replace this -5x with 3x minus 8x, or 8x minus 8x plus 3x. I'm going to use these two terms right here, and I'm going to split that middle term. See what I did there? Negative 8x plus 3x gives you negative 5x. Now, this is called factor by grouping. Factor by grouping says take those four terms and separate them into two groups. Now I'm going to find the greatest common factor in each group. Each one of these terms in this group is divisible by x. So there's a GCF of x there. Each one of the terms in this group here are divisible by 3. So here I factored out an x, here I factored out a 3. X times x gives me x squared. X times negative 8 gives me negative 8x. Over here, 3 times x gives me 3x. 3 times negative 8 gives me negative 24. If you're factoring using this method, here we have what's called a common binomial factor, which is actually a GCF in each one of those terms. So if I factor it out, that takes it out of that one and it takes it out of that one. What's left to go in the next set of parentheses is the x and the plus 3. Now when I taught you this in the last lesson, I used the shortcut. If your a is 1, there's a shortcut. See the 3 right here? Positive 3 right here. See the negative 8 here? Negative 8 here. Let me say that again. If your a equals 1, you can skip all of that. Use these and plug them straight into the answer. Okay? If a equals 1. See how that works? Yeah. Okay, so now we're going to check with FOIL. Front two terms gives me x squared. Outside two terms is a plus 3x. Inside two terms is negative 8x. Last two terms gives me negative 24. We saw that right up here. If you combine like terms here, you get negative 5x. And that looks like this. So I know my factoring is correct. That's not the final answer, though. Remember, that whole thing was set equal to 0. So I'm going to take those two factors back to my original equation and set it equal to 0. So this quantity of x minus 8 times the quantity of x plus 3 is just the factored form of that trinomial. They mean the same thing. Now, I'm going to set each factor equal to 0. Remember, if you have a times b and the product is 0, then either a has to be 0 or b has to be 0. So I'm going to set each one of those factors equal to 0 and solve. I'm going to add 8 here and I'm going to subtract 3 over here. So I get x equals 8 or x equals negative 3. How do I check that answer now? Well, you take those numbers and you plug them back into the original equation. If I plug in 8 for x and I do the math, I do get 24. Check. If I plug in negative 3 for x, and look at what I did here, you have to wrap parentheses around that negative 3 before you square it. I also get 24. So we know the solutions are 8 and negative 3.